Hey guys, what's up? My name is Mohit K. Kashyap and I'm from SVC College of Engineering. Today I'm going to explain you guys about CAN bus, LIN bus, and Modbus protocol and message frame format. So moving on to the next slide. So the full form of CAN bus is a control layer network, and the CAN bus system enables each ECU to communicate with all other ECUs without complex dedicated wiring. Especially an ECU can prepare and broadcast information via the CAN bus. Considering of two wires, CAN low and CAN high, the broadcasted data is accepted by all other ECUs on the CAN network, and each ECU can check the data and decide whether to receive or ignore it. So as you can look at the diagram, there's a gateway. Gateway is a medium for interpretation of data. So there are many CAN buses joined with the gateway, and on the right side you can look at the flow chart. The first one is application, presentation, session, transport network, data link, which are linked to logic circuit control, media access control, physical coding, physical media attachment, physical media dependent. So moving on to the next slide. So what is a CAN frame? So communication over the CAN bus is done via CAN frames. Below is a standard CAN frame with 11 bits identifier, which is the type used in most cars. The extended 29-bit identifier frame CAN 2.0B is identical, except the longer ID for heavy-duty vehicles. So what is SOF? SOF means the start of frame is a dominant zero to tell the other nodes that a CAN node needs to intends to talk. What is an ID? The ID is a frame identifier. Lower values have higher priority. RTR, the remote transmission request, indicates whether a node sends data or requests dedicated data from another node. Control. The control contains identifier extension bit, which is a dominant 0 for 11-bit. It also contains the 4-bit data length code that specifies the length of the data types to be transmitted, which is usually 0 to 8 bytes. What is the data? The data contains the data bytes, aka payload, which includes CAN signals that can be extracted and other information. CRC, the cyclic redundancy check, is used to ensure data integrity. ACK, the ACK slot indicates if the node has acknowledged and received the data correctly. So what is EOF? The EOF marks the end of CAN frame. So let's look at the standard CAN frame, picture of standard CAN frame, which is so it starts with the SOF, followed by the ID, then RTR control, then data, then CRC, then AKC, then ACK, and EOF. So let's move on to the next slide. So now let's get started with LIN bus protocol and its message format. It offers lower performance and reliability, but also drastically lower costs. Below, we provide a quick overview of LIN bus and a comparison of LIN bus versus CAN bus. So as we can look at the points, which is LIN bus is low cost option. It is a low cost option with if speed fault tolerance are not critical. Then often used in vehicles of window wipers, air conditioner, etc. Single wires with 1 to 20 kilobits per second at max 40 meter bus length. Time triggered scheduling with guaranteed latency time and a variable data length. LIN supports error detection, checksums and configurations, operating voltage of 12 volts, physical layer based on ISO 9141, sleep mode and wake up support. Most newer vehicles have 10 plus LIN nodes. So I'll get this LIN master node, header, response, everything's okay. So what is the LIN bus frame format? So as we can look at the diagram, there's a header, there's a response. So what is break? So break is the synthetic break field as SBF, aka break in minimum 13 plus 1 bits long. The break field acts as a start of frame notice to all lin loads on the bus. Also, the next point is sync. The 8-bit sync field has a predefined value of 0x55, which is in binary, which is 0101101. The structure allows the lin nodes to determine the time between rising or falling edges, and thus the baud rate used by the master node. This lets each of them stay in sync. So the next one is identifier. The identifier is 6 bits followed by 2 parity bits. The ID acts as an identifier for each lin message sent and which nodes react to the header. Slaves determine the validity of the ID field and act via below. Ignore the subsequent data transmission. Second one, listen to the data transmitted from another node. Third one is published data in response to the header. Typically, one slave is pulled for information at a time, meaning zero collision risk. Note that the 6 bits allow for 64 IDs, of which ID 60 to 61 are used for diagnostics and 62 to 63 are reserved data. When a lin slave is polluted by the master, it can respond by transmitting 2, 4, 8 bytes of data. So the data is customized, but it is typically linked to the ID range. So let's move on to the next slide. The automotive most bus is a high-speed multimedia network that enables seamless communication between various components within a vehicle. It serves as a backbone for transmitting audio, video, and control signals, facilitating most facilitating the integration of infotainment, driver assistance, and other vehicle systems. Now, the MOSBus was designed to carry high bandwidth multimedia data over the vehicle. It was initially specified in the 1990s through joint effort from BMW, Becker Harman, and OSS Silicon. Over time, the consortium expanded to include more members, and today our OEMs use the automotive MOSBus to carry the multimedia data. Below, you can look at the beautiful figure. Let's go and explain the whole idea of this concept. So in this slide, we are discussing on media-oriented system transport format, frame format. So the media-oriented system transport bus uses a specific frame format for transmitting data and control signals between network nodes. Understanding this frame format is essential for analyzing and interpreting data exchange on the bus. The frame format of the MOS25 protocol consists of 1 byte header with 4 bits used for synchronization purposes. The remaining bits in the header indicate the number of quadrils available for streaming data in the packet. Control data and frame control information follow the header, with the size of each control message being 32 bytes. So as you can look at the graph, look at the flowchart. The first one is application, followed by presentation, session, transport, network, data link, and physical. So moving on to the next slide. So thank you guys. Thank you for watching my video. I hope you guys liked it. So bye bye. Good night, guys. Have a nice day.